So what are we going to do today? We're going to be able to use the chain rule to take the derivative of functions that are nested inside of each other. How are we going to do this? We're going to be able to identify the outside and the inside functions, and then we will use the chain rule. And one of the reasons why we learn chain rule is because it's going to make a lot of things much, much easier. And it's going to also motivate slightly simpler ones that we technically couldn't do before, but now we'll see that they're actually very easy to do. We'll talk about those as we go. Um, but first of all, let's talk about what the chain rule actually is. So the chain rule basically says if you've got a function that's got a whole expression inside of it, we're going to call u, and you're going to see this u pop up over and over again. But like we're going to have a whole expression in there that sort of makes our problem otherwise unworkable. What we can do is we can take the derivative of the outside part and then multiply that by the derivative of the inside part. So before we get into like complicated stuff, and a lot of today is going to be about identifying the outside, identifying the inside, let's talk about some stuff before we get into like very specific problems and concepts. Let's talk about how this is actually used. So let's start with something simple. So before, we wouldn't have been able to do this. Like we didn't have the capacity or the toolkit to be able to take the derivative of something like this. But now we do. What we can do is we can identify the outside. The outside is the sign, right? And then identify the inside. The inside is this 3x plus 1. So remember what we said. First, you'll take the derivative of the outside, and then you'll take the derivative of the thing that's on the inside and multiply it. And then you'll have what you need. So the derivative of sine, right, is cosine. So we took the derivative of the outside part, but now I still need to take the derivative of the inside part. Well, what's the derivative of 3x is just 3. What's the derivative of 1? Well, that's 0. So my final answer, my final answer in this derivative, and I just took the 3 that was over here on the end and I moved it out to the front because it looks nicer. But so basically I take the derivative of the outside shell, leave what's inside alone, and then I'm going to multiply that by what's here on the inside of the function and the derivative of that, right? So notice, step 1, derivative of the outside. Step 2, multiply by the derivative of the inside. It may help. I don't know if it does, but it may help to write it out sort of like what we've been doing with our multiplication and product rules. So what we can do, and here's how I'll show it. We're going to write out these, and we're going to write out these. So the outside function is sine. The derivative of that, well, what's the derivative of sine is cosine. The inside function is 3x plus 1. And the derivative of that function, the derivative of 3x plus 1 is just 3, right? So now all we have to do, we've got all the things that we needed. Now we can just take the parts that matter. Cosine of u times the derivative of u And now we're just going to neaten it up and put in what u is, right? And that's all we're doing. So now all we're missing is saying, okay, well, 3 times the cosine of u, which is 3x plus 1. And that's what I had before, right? I've just sort of did it in a different way. I think breaking it down like this helps make life a lot easier. Breaking it down like this helps make life a lot easier because then you can go through and say, all right, well, I need f prime of u and I need du dx. I can find f prime of u real easy. I can find du dx real easy. And there's my final work. And that's all there is to it, okay? Let's do a couple more of these before we get into, let's say, some of the slightly more complicated stuff. We're going to add a blank page after the current. There we go. And let's look at another really common thing to happen. So let's call our f e to the x squared power. Well, oh my God, how do I do that? I can't do that right now. I know e to the x, but I don't know e to the x squared. What can I do? And so let's break it down. What's our outside function? It's the e, right? And we're just going to take whatever garbage is up here and we're going to replace it with a u for now. And now we can do this one. The derivative of this is just e to the x. Or e to the u, I guess it would be. Right? Now it's our u, x squared. That's the thing that we replaced from up here. So if we're going to take the derivative with respect to x, we can do that now. What's the derivative of x squared? Bring down the exponent and lower the exponent by 1. So now, f prime of u, right? So now, remember the derivative of this, f prime of u times du dx. So what's f prime of u? That's e to the u. What's du dx? Times 2x. And then let's just replace what u is. So our derivative, and I'm going to take this 2x and bring it up to the front because it looks prettier that way. 2x e to the x squared. And now we're done. So we're looking at stuff like this. Simple things that we can break down very easily. Now, one of the reasons why chain rule is so important, and I hope I can motivate you with today why it's so important, is because you can take problems that would have otherwise been absolutely hellacious and you can turn them into something that's much, much easier. Let's say I told you to find the derivative of this function without the chain rule. You'd sit there and you'd say, Mr. Webster, you're telling me you want me to do the product rule like 6 different times to be able to do all this? And I'd tell you, yeah, that's what you would have to do. You have no choice. But now with the chain rule, a problem like this is so easy. Here's why. Once again, our outside function is just something to the 5th. So let's just call that u to the 5th, right? This inside is raised to the 5th power. Well, what's the derivative of that? Isn't that 5 u to the 4th? Well, now let's look at what u was. U, we said, was the inside. X to the 4th plus 3x squared minus 5x plus 2. And now your du dx, we can take the derivative of this thing. Well, just each of these pieces individually, right? Derivative of x to the fourth, 4x cubed, plus the derivative of 3x squared, that's bring down the 2, 2 times 3 is 6, x to the first, minus the derivative of 5x is just 5, plus 2, the derivative of 2 is just 0, so we don't have to put it. But now look, remember we said that the derivative of this thing, this ugly thing, is just the derivative of the outside times the derivative of the inside. So let's write that out. U to the fifth times 4x cubed plus 6x minus 5. And as our final step, instead of u, we'll put, and I'm sorry, I copied the wrong line, didn't I? The prime u. 5u to the fourth. There we go. My apologies for that. And all we still have to do is just take this 5u to the fourth and replace that u with our x expression, right? So what's our final answer? It's just 5 times x to the fourth. It's always the 4s that get me. X to the fourth plus 3x squared minus 5x plus 2 raised to the fourth power times this thing over here. So what I've presented to you is one way of thinking about it. Eventually, my goal as the person presenting you this material, as your teacher, is that by the time you're done with this process, it shouldn't take this long to do. That is to say, you should be able to, with practice, be able to say, all right, well, here's my function. And you should be able to take the derivative of it quicker. Okay, derivative of the outside, take the 5, bringing it down. Times the derivative of the inside. And ta-da. And what I'm telling you is that by the time you get used to doing this problem, which would have taken you like a year and a half to do, should take you 15 seconds to do. Okay, what I want to do is I want to go over some examples. I've stolen these from the Math Excel, and what they're having us do is they give you this y, they tell you is f of u. They give you your u. So just like what we did in practice, here's our f of u. Here's our derivative. Should just be 8, right? Here's our u. 1/4 x to the 8. I don't know why the 1/4 is in parentheses here, but that's okay. And here's our du. Well, let's bring the 8 down. 8 over 4 is 2. We bring the 8 down, and now it's a 7. So now once again, remember, they're writing it out with the functions like this, but it's the same thing. f prime of u times du dx. They're telling you here, the reason they've written it this way is they're telling you that g of x is u, and they're just writing it in a different way so that you can see it. Okay, but you go through, it's still the same process. F prime of u times du dx. And what we can do here is we can simplify this because you've got 8 times 2 is 16, right? And that's my answer. So once again, they've broken it up for you in these. In some of the subsequent ones, they won't. And that's okay. You can either do it yourself or you can skip straight to the chase, like what I was talking about earlier. So let's look at the next one. Same thing here. They've given us our f of u and they've given us our u. So we can literally just go right to the side of the paper and write it down. Find our f prime. Well, the derivative of cosine is just negative sine. And the derivative of 7x minus 4. Well, what's the derivative of 7x is just 7. What's the derivative of minus 4 is just 0. So we've got our problem now. So we've got negative sine u times 7. And we don't want to leave u in there. We want to rewrite it back out in terms of x. So we've got our final answer, negative sine of what our u is, that 7x minus 4 times 7. And because I like to write it with the numbers up front, I'm just going to say negative 7 sine of 7x minus 4, just to make it look nice for my final answer. But you don't have to do that. I mean, you can leave it. You could leave it here or here. Both of these steps are correct. Both of these are correct answers. On a AP exam, either of these should be acceptable. Remember, make that grader work for their money. All right, let's look at a second one. Once again, they've given you a lot of what you need already. So they've given you f of u, and that's this. Now, here's what I'm going to say is that this is written really ignorantly with that fourth root and that cube there. Why not just write it as u to the 3/4, right? The index of a root is the denominator of the exponent. The exponent here is the numerator, and then now you're good. And now we can take the derivative of this, bring down the exponent, and then make the exponent go down by 1. It was 3/4. Now it's 3/4 minus 1, which is negative 1/4, right? So there's that part. Now we can do our u, which is sine of x. Now we can do our du, which is the derivative of sine, which is cosine. So from here, again, all we have to do is write out our answer, f prime of u times du dx. Well, what is that? That's 3/4 u to the negative 1/4 times the cosine of x. Now all we have to do is put u back in, which is sine. And there we go. That is our final answer. All right, same thing, same exact thing. here we've got our f of u, which is negative 3 cosine of u. So our derivative, well, the derivative of cosine is negative sine. So we're going to bring out a negative as well. So if negative 3, which is positive 3, right? And now we're going to take our u and do the derivative of that. The derivative of 7x is just 7. The derivative of negative 4 sine x, that's just negative 4 cosine x. Right? You know, and our u is right here. I'm going to, you know, we can do a lot of writing. We don't have to do as much writing, especially when there are already things here, right? But either way, we want our f prime times our du dx, and so we get 3 times the sine of u times negative 7 minus 4 cosine of x. And now I'm going to replace u with our original function here. We got 3 sine of 7x minus 4 sine times 7 minus 4 cosine x. And that is my final answer, right? Again, let's keep going. We've got a lot of these, but let's look at this one again. This is something like what we talked about earlier, right? I want to be able to find the derivative of e to the x to the fourth. So our basic function here is our e function, right? The derivative of that is just the same thing, right? And the reason we're doing this is because we want to have u be x to the fourth, right? That way we can take the derivative of that, for x cubed. And now once again, all we have to do is we have to take our f prime and our du dx and put them together. E to the u times our du. And then just take a second and rewrite with, instead of u, back in terms of x. And again, for me personally, I like to put the e at the end. I just like to do it this way because it tends to make it easier to write without all the extra timeses and parentheses and stuff like that. That's just me. You can leave it here or you can leave it here. Both of these answer choices are potentially fine in terms of writing them out. Each of them, you know, if you're on a multiple choice, you should be expecting to see an answer that looks like this last one, though. Okay, I think I've got 2 more. Here I've got a cosine with a sine inside of it. And so I'm going to do this 2 different ways, just because I want you to see the sort of slow, methodical way that we've been doing it versus quick way. Because eventually it will make life easier for you, and it will make this whole chain rule thing feel more worth it if you can just bang these out. And I'll tell you how. So let's do it the slow way first, just so you can see. So we've got our f of u, and our outside function is cosine. So we've got cosine of u. Our f prime is negative sine. And now we've got our u, which is our inside function, which is sine. And the derivative of that is cosine. So we're going to do f prime times du. So we've got negative sine u times cosine of x. And then we're going to put in what is u? Well, so we got negative sine of x times cosine of x. And that's our final answer right here. So once again, you can totally always do it this way. Please feel free to always do it this way if it makes sense to you, if you like it, if it's comfortable. But one of the things I'm going to tell you is that eventually it's going to make it a lot easier for you to just do it, right? Okay, I'm looking at the outside. The derivative of cosine is negative sine. Then I multiply by the inside derivative. The derivative of sine is cosine. And look, my final answer. Same thing what I got down here as what I got up here. And it's just two different ways of thinking about it. Some of you are going to really like this methodical way. Some of you are really going to like sort of this in the head way. And I'm not telling you that one of them is the wrong process, because it's not. They're both fine to do. But here's what I will tell you is that when you do the right-hand side way, you see a lot better what's going on. You're less likely to make a mistake because you're writing out all the steps. And if you do make a mistake, it is much easier to see what you have done wrong. When you do it this way, and again, if it works for you, do it this way. You are sacrificing potential accuracy and potential readability for the ability to go faster. I'm not telling you which one is right or which one is wrong, because it's not. There's no right, there's no wrong, but I will tell you that this one is faster. This one will get you through it quicker, especially if you're good at this and you can do it in your brain. This one is more likely to be right. And if you are feeling concerned about your sort of organizational ability up in your brain, which I often am, that's just me as a person. This way, especially towards the beginning, is going to help make a lot more sense. But I'm not telling you one way is right or one way is wrong. They're both great. As long as you get the right answer, you're good. Here's one more. And the reason I wanted to show you this one is because this one actually has 3 different layers. And I'm going to begin by saying I hate this notation. I think I've said this before. I hate this notation, this sine squared of whatever. Everything makes a lot more sense when it's written like this. Because see, now I see there's an outer function, there's a function in the middle, and then there's an inner function. So what's going to end up happening is I'm going to be doing the chain rule twice, right? So, watch. First, I'm going to take the derivative of the outer function. And notice all I did was I pretended like this was just one big giant x, and I brought the 2 down, and I left the inside alone. Now I'm going to take the derivative of this inside bit. Well, what's the derivative of sine? Cosine, right? And again, leave the insides alone. And now finally, I still have a whole nother inside to deal with, and I'm going to take the derivative of that one. Well, what's the derivative of 7 pi t? Well, 7 pi is a number, right? It's like 22, 23-ish. So 23 pi minus 8. So I'm just going to be left with 23. 23t minus 8. So I'm just going to be left with the 23, which is 7 pi, right? And then I'm going to take the derivative of the minus 8, and minus 8's derivative is just 0. So that's the end of that part. And now there's no inner function to continue working on. So now I'm going to rewrite it so that it looks much neater, right? I'm going to take all the numbers and I'm going to combine them up. The 2 and the 7 pi. That's 14 pi out front. And then you've got a sine with stuff in it and a cosine with stuff in it. We're just going to do that. Times sine with this stuff in it. And then cosine with this stuff in it. And I will point out this is a 2, so this whole outer function kind of went away. If this was like a 5 in here, if this was like a 6 and we took the derivative, this became a 5, we wouldn't be able to take the exponent stuff away, right? And we wouldn't just be able to write it like this. It would be like a 5 here, sine times sine of 7 pi t minus 8 to the 5th or something. Okay. All right. So I purposely did not do everything. On Thursday, we're going to continue with this very assignment, with this very concept, just doing much more complicated problems.